Is there a reason to keep Windows primary partition, drive C, small? In my jobs almost 2 decades ago, experts would keep the size of Windows main partition, C drive, extremely small compared to the other partitions. They would argue this runs PC at optimum speed without slowing down. But the downside of it is, C drive easily fills up if kept small, and soon you can't install new software as it runs out of space. Even if I install software in D drive, part of it is always copied to C, which fills it up. My question is, this practice still good? Why it is done? What are its main advantage, if any? One obvious one is if primary partition crashes, your data is safe in secondary. The reason I am asking this question is because I am trying to update Visual Studio and I can't because I have only 24 MB left in primary partition.
In my jobs almost 2 decades ago, experts would keep the size of Windows main partition, C drive, extremely small compared to the other partitions. They would argue this runs PC at optimum speed without slowing down. My question is, this practice still good? In general, no. In older Windows versions, there were performance problems with large drives, more accurately, with large file systems, mainly because the FAT file system used by Windows did not support large file systems well. However, all modern Windows installations use NTFS instead, which solve these problems. C, for example, does NTFS performance degrade significantly in volumes larger than 5 or 6 TB, which explains that even terabyte-sized partitions are not usually a problem. Nowadays, there is generally no reason not to use a single, large C partition. Microsoft's own installer defaults to creating a single, large C drive. If there were good reasons to create a separate data partition, the installer would offer it. Why should Microsoft let you install Windows in a way that creates problems? The main reason against multiple drives is that it increases complexity, which is always bad in it. It creates new problems, such as you need to decide which files to put onto which drive, and change settings appropriately, click stuff in installers, etc. Some badly written software may not like not being put onto a drive different than C. You can end up with too little free space on one partition, while the other still has free space, which can be difficult to fix. There are some special cases where multiple partitions still make sense. If you want to dual boot, you, usually, need separate partitions for each OS install, but still only one partition per install. If you have more than one drive, particularly drives with different characteristics, such as SSD and AMP, HD, you may want to pick and choose what goes where. In that case, it can make sense to, for example, put drive C on the SSD and D on the HD. To address some arguments often raised in favor of small/separate partitions. Small partitions are easier to back up. You should really back up all your data anyway, so splitting it across partitions does not really help. Also, if you really need to do it, all backup software I know lets you selectively back up a part of a partition. If one partition is damaged, the other partition may still be okay. While this is theoretically true, there is no guarantee damage will nicely limit itself to one partition, and it's even harder to check to make sure of this in case of problems, so this provides only limited guarantee. Plus, if you have good, redundant backups, the added safety is usually too small to be worth the bother. And if you don't have backups, you have much bigger problems. If you put all user data on a data partition, you can wipe and reinstall, not back up the OS partition because there is no user data there. While this may be true in theory, In practice, many programs will write settings and other important data to drive C, because they are unfortunately hard-coded to do that, or because you accidentally forgot to change their settings. Therefore, it is very risky to rely on this. Plus, you need good backups anyway, see above, so after reinstallation you can restore the backups, which will give you the same result, just more safely. Modern Windows versions already keep user data in a separate directory, user profile directory, so selectively restoring is possible. See also, will you install software on the same partition as Windows system? For more information.
The historical reason for this practice is most likely rooted in the performance properties of rotating magnetic HDDs. The area on spinning disks with the highest sequential access speed are the outermost sectors, near the start of the drive. If you use the whole drive for your operating system, sooner or later, through updates etc., your OS files would be spread out all over the disk surface. So, to make sure that the OS files physically stay in the fastest disk area, you would create a small system partition at the beginning of the drive, and spread the rest of the drive in as many data partitions as you like. Seek latency also partly depends on how far the heads have to move, so keeping all the small files somewhat near each other also has an advantage on rotational drives. This practice has lost all its reason with the advent of SSD storage.
Short answer, not anymore. In my experience, 20+ years of it adminship work, the primary reason for this practice, others are listed below, is that users basically didn't trust Windows with their data and hard drive space. Windows has long been notoriously bad at staying stable over time, cleaning after itself, keeping the system partition healthy and providing convenient access to user data on it. So users preferred to reject the file system hierarchy that Windows provided and roll their own outside of it. The system partition also acted as a ghetto to deny Windows the means to wreak havoc outside of its confines. There are lots of products, including those from Microsoft, that don't uninstall cleanly and or cause compatibility and stability issues. The most prominent manifestation is leftover files and registry entries all around in DLL hell in all of its incarnations. Many files created by the OS are not cleaned up afterwards, logs, Windows updates etc., leading to the OS taking up more and more space as time goes. In Windows 95 and even XP era, advice went as far as suggesting a clean reinstall of the OS once in a while. Reinstalling the OS required an ability to guarantee wiping the OS and its partition, to also clean up any bogus data in the file system, impossible without multiple partitions. And splitting the drive without losing data is only possible with specialized programs, which may have their own nasty surprises like bailing out and leaving data in an unusable state upon encountering a bad sector. Various cleanup programs alleviated the problem, but, their logic being based on reverse engineering and observed behavior, were even more likely to cause a major malfunction that would force a reinstall. For example, the reclean utility by MS itself was called off after Office 2007 release that broke assumptions about the registry that it was based on. The fact that many programs saved their data into arbitrary places made separating user and OS data even harder, making users install programs outside of the OS hierarchy as well. Microsoft tried a number of ways to enhance stability, with varying degrees of success: shared DLLs, Windows File Protection and its successor Trust Installer, side-by-side subsystem, a separate repository for net modules with storage structure that prevents version and vendor conflicts. The latest versions of Windows Installer even have rudimentary dependency checking, probably the last major package manager in general use to include that feature. With regard to third-party software compliance to best practices, they maneuvered between maintaining compatibility with sloppily written but sufficiently used software, otherwise, its users would not upgrade to a new Windows version, which lead to a mind-boggling amount of kludges and workarounds in the OS, including undocumented API behavior, live patching of third-party programs to fix bugs in them, and a few levels of registry and file system virtualization, and between forcing third-party vendors into compliance with measures like a certification logo program and a driver signing program, made compulsory starting with Vista. User data being buried under a long path under the user's profile made it inconvenient to browse for and specify paths to it. The paths also used long names, had spaces, a bane of command shells everywhere, and national characters, a major problem for programming languages except very recent ones that have comprehensive Unicode support, and were locale-specific, and unobtainable without WinAPI access, killing any internationalization efforts and scripts, all of which didn't help matters, either. So having your data in the root dir of a separate drive was seen as a more convenient data structure than what Windows provided. This was only fixed in very recent Windows releases. Paths themselves were fixed in Vista, compacting long names, eliminating spaces and localized names. The browsing problem was fixed in Win 7 that provided start menu entries for both the root of the user profile and most other directories under it, and things like persistent favorite folders and file selection dialogues, with sensible defaults like downloads, to save the need to browse for them each time. All in all, MS efforts bore fruit in the end. Roughly since Win 7, the OS, stock and third-party software, including cleanup utilities, are stable and well-behaved enough, and HDDs large enough, for the OS to not require reinstallation for the entirety of a typical workstation's life. And the stock hierarchy is usable and accessible enough to actually accept and use it in day-to-day practice. Secondary reasons are: early software, file system and partitioning support in BIOS and OCs, were lagging behind hard drives in supporting large volumes of data, necessitating splitting a hard drive into parts to be able to use its full capacity. This was primarily an issue in DOS and Windows 95 times. With the advent of FAT32, Windows 98, and NTFS, Windows NT 3.1, the problem was largely solved for the time being. The 2 TB barrier that emerged recently was fixed by the recent generation of file systems, ext4 and recent versions of NTFS, GPT and 4K disks. Various attempts to optimize performance. Rotational hard drives are slightly, about 1.5 times, faster at reading data from outer tracks, which map to the starting sectors, than the inner, suggesting locating frequently accessed files like OS libraries and page file near the start of the disk. Since user data is also accessed very often and head repositioning has an even larger impact on performance, outside of very specific workloads, the improvement in real-life use is marginal at best. Multiple physical disks. This is a non-typical setup for a workstation since a modern HDD is often sufficiently large by itself and laptops don't even have space for a second HDD. Most if not all stations I've seen with this setup are desktops that reuse older HDDs that are still operational and add up to the necessary size. Otherwise, either a RAID should be used, or one of the drives should hold backups and not be in regular use. This is probably the sole case where one gets a real gain from splitting system and data into separate volumes. Since they are physically on different hardware, they can be accessed in parallel, unless it's two PATA drives on the same cable, and there's no performance head-on-head repositioning when switching between them. To reuse the Windows directory structure, I typically move C:\users to the data drive. Moving just a single profile or even just documents, downloads in desktop proved to be inferior cause other parts of the profile and public can also grow uncontrollably. See the separate configuration and data setup below. Though the disk can be consolidated into a spanned volume, I don't use or recommend this because dynamic volumes are a proprietary technology that third-party tools have trouble working with, and because if any of the drives fails, the entire volume is lost. An M.2 SSD plus HDD. In this case, I rather recommend using SSD solely as a cache. This way, you get the benefit of an SSD for your entire array of data rather than just some arbitrary part of it, and what is accelerated is determined auto-magically by what you actually access in practice. In any case, this setup in a laptop is inferior to just a single SSD cause HDDs are also intolerant to external shock and vibration, which are very real occurrences for laptops. Dual boot scenarios. Generally, two OCs can't coexist on a single partition. This is the only scenario that I know of that warrants multiple partitions on a workstation. And use cases for that are vanishingly rare nowadays anyway, because every workstation is now powerful enough to run VMS. On servers, there are a number of other valid scenarios, but none of them applies to super users' domain. For example, one can separate persistent data, programs and configuration, from changing data, app data and logs, to prevent a runaway app from breaking the entire system. There are also various special needs. For example, in an embedded system, persistent data often resides on an EEPROM while work data on a RAM drive. Linux's file system hierarchy standard lends itself nicely to tweaks of this kind.
I'm a software developer, but also have spent time doing regular back office at work. I typically keep the OS and applications on drive C, and my personal files on drive D. These don't necessarily need to be separate physical drives, but currently I am using a relatively small SSD as my system drive, C, and a traditional disk drive, i.e. with rotating magnetic platters, as my home drive, D. All file systems are subject to fragmentation. With SSDs this is basically a non-issue, but it is still an issue with traditional disk drives. I have found that fragmentation can significantly degrade system performance. For example, I've found that a full build of a large software project improved by over 50% after defragmenting my drive, and the build in question took the better part of an hour, so this was not a trivial difference. Keeping my personal files on a separate volume makes, I have found, the system volume doesn't get fragmented nearly as quickly, or severely. It is much faster to defragment the two separate volumes than a single volume with everything on it. Each volume takes 20% to 25% as long as the combined volume would. I've observed this on several generations of pieces, with several versions of Windows. As a commenter pointed out, this also tends to facilitate making backups. I should note that the development tools I use tend to generate a large number of temporary files, which seem to be a significant contributor to the fragmentation issue. So the severity of this issue will vary according to the software you use. You may not notice a difference, or as much of one. But there are other activities, for example video, audio composition and editing, which are I/O intensive, and depending on the software used, may generate large numbers of temporary, intermediate files. My point being, don't write this off as something that only affects one class of users. Caveat: with newer versions of Windows, from 8 onward, this has become much more difficult, because user folders on a volume other than C are no longer officially supported. I can tell you that I was unable to perform an in-place upgrade from Windows 7 to Windows 10, but there are a number of different ways to relocate a user folder. I don't know which are affected. One additional note: if you maintain 2 separate volumes on a traditional drive, you may want to set up a page file on the D volume. For the reasons described in Wushell's answer, this will reduce seek time when writing to the page file.
Ifjałowany sposób podde handel, pracę sąsiedztw streaming.